Okay, hope you guys are having a good day. What we're moving on to today is exponential growth and exponential decay, as well as compound interest. So what these guys are used for is to model situations where we have either exponential growth or exponential decay. So we actually have a little formula for exponential growth that looks like this. F of t equals a times 1 plus r to the t power. Right? So here's what each of those variables represent. A represents the initial amount, how much we are starting with. R represents our rate, and in this case we'd consider our growth rate, and this must always be written as a decimal. So if you're given a percent, you got to make sure that you rethink that guy as a decimal, which is pretty easy to do. I'll show you if you're not sure on how to do that. And then t just represents time. Right? So let's go ahead and try out a few where we're dealing with exponential growth. Right? So here we have the original value of an investment is $1,800. If the value is increased by 7% each year, write an exponential function to model the situation. Then find the value of the investment after 15 years. So we know this is going to be a growth because when you invest money, it's going to keep increasing in value. Okay, so let's list out the things we know. We know our A value is 1,800. That's how much we started with, right? Our R value is 7%, but I'm going to rewrite that as 0.07. All I had to do was take the decimal point, which is right there in this case, and move it 2 to the left, and that will convert a percent to a decimal. And then finally, my T value is 15 years. So what I can do is I can just plug in all that information and then solve this guy out. What I would do is always try and simplify down anything that is easy to simplify. For example, 1 plus 0.07, I can just do that right there. So if you're using a graphing calculator, the way we'd plug this in is 1,800, and then we would do 1.07 to the 15th power, and we get an answer of $4,966.26. I rounded to the hundredth because it's money, right? And if you don't have a graphing calculator, what I would suggest is go to google.com and type in calculator, and their calculator is pretty solid, and you'll be able to do all this. Okay, so let's check out another. All right. Well, actually, you know what? Give number 2 a try. All right, so pause the video, and then when you unpause it, I'll complete this and you can check your work. Okay, so I had an A value of 972, R value of 0.015. Remember, I had to convert that to a decimal. And then my T, I had to think a little bit. Okay? It looks like we started in 2002, and we're checking how many kids are going to be enrolled in 2014. So that's going to be 12 years. I just did 2014 minus 2002. Right, so you should have set up something that looked like this. Remember to simplify it down a little bit, and then just plug it in your calc. And it looks like you get something like 1,162 students. Cool. So, on the other hand, we also have opportunities to use exponential decay to model scenarios. So that's when something is decreasing exponentially. Okay, so this guy is actually going to be the same exact formula except for one change. Instead of adding our R value, we're going to subtract it. Okay, so it looks really similar. Okay, and everything is representing the same thing in terms of our variables, except for this guy would now be considered our decay rate. And once again, it must be written as a decimal. Okay, and then our T value is just time. So when you're trying to decide whether something's a growth or decay, look out for keywords. For example, in number 3, it says an investment of $12,000 is losing value. Right when you see losing value, you should be thinking that's a decay. Right? Write an exponential function to model the situation and find the value of investment after 9 years. So we started with $12,000. We're losing 4% each year, so that's 0.04 when I convert it to a decimal. And my t-value is 9, so I would just do 12,000, and then we have 1 plus 0.04, and actually, sorry, minus 0.04, right, because we're dealing with a decay. So that's going to be 0.96 to the 9th. I go ahead and I can put this in my calculator. And it looks like I get something like $8,310.41. Okay, so you go ahead and try number 4 out on your own. So pause the video, give it a go, and then when you're done, unpause, and I'll show you what this one should have looked like. Should have had something that looks like this. So A value of 35,000, R value of 0.08. I was subtracting it because it's decay, and a T value of 7. Okay, and then you can go ahead, simplify it down a little bit, and plug it in your calc, and you should have got something like 19,524.63. Okay. So the last thing I want to show you is one more formula, and that's our compound interest formula. So whenever you're putting money in the bank, right, you are receiving interest in some way or another, and this is the way that it is calculated. Our formula for compound interest is a little bit more complicated. It looks like this. A equals P times 1 plus R over N to the NT power. Right? And then this is what each of those variables represent. P is our principal, which is a fancy word just to say the initial amount. And then R, once again, is our rate. N is the number of compounds per year. And that just means how many times are they calculating the interest per a year. And then T is time. So let's go ahead and check out one or two examples. Okay? So for number 5, it says Laura deposited $12,000 into an account that earns 8% interest. How much money will she have in 5 years if the interest is compounded quarterly? Okay, so a few of these things are easy to find. Our P value is just how much we started with, easy, 12,000, right? R value is pretty easy as well. Remember, it has to be written as a decimal. So instead of 8%, I'm going to do 0.08. Our T value is also pretty easy. It just gave it to us 5 years. And we have to think a little bit. You got to look for key words here. In this problem, it says compounded quarterly. Quarterly means 4 times, right? There's 4 quarters in a basketball game, and so quarterly is 4. And so now that we have all these values, we can go ahead and just plug them all into our formula. So I'm going to do 12,000. It's be 1 plus 0.08 over 4, all raised to the 4 times 5 power. Right? So what I like to do is definitely make sure that you simplify this guy down a little bit. Sometimes you might need your calculator. For example, I might do 1 plus 0.08 divided by 4. That's going to be 1.02. 4 times 5 is 20. And now I have something that's a little bit easier to plug in to your calculator. Okay, so I got 17,831 and 37 cents. Right? So whenever you see that word compound, that's when you're going to be going ahead and using our compound interest problem here. So try out number 6, pause the video here, and when you're done, unpause it, and we'll check and see how your work went here. Okay, so I'm going to go ahead and get started. Right. Okay, so it was n value of 12, and that was because it was monthly there, and t value of 6. So go ahead and plug everything in. And remember, go ahead and simplify it down a little bit. And when you plug all this in, I got something like $32,732.58. Okay, so let's look at one more just to get used to our, let's go to number 9. Right? And here we got to be pretty clever. It says, suppose you invest $750 into an account that pays 3% interest compounded weekly. How much interest will you have earned after 20 years? So in this scenario, we have to realize that we are going to actually just be finding the interest, not the overall total. So once we get our answer, we're going to have to take that original $750 we put in and take it away from that answer to get how much interest we earned. So other than that, we're keeping it pretty simple. We're going to do $750 for our p-value. R is going to be 0.03. Looks like our n value is going to be weekly. So remember, there's 52 weeks in a year. And then finally, our t value is going to be 20. So what we can do is something that looks like this: 750, then we got 1 plus 0.03 divided by 52, and then we have 52 times 20 as our power. So this guy is going to be 750. When I put all this in my calc, you're going to get something like 1.000576923. I know it's a lot, but we want to be pretty accurate here. And then 1040 is the 52 times 20. So the answer I get for my overall total is something like this. But remember what I said earlier, we're just trying to find how much interest we've gotten. So that's going to be taking our total and taking away how much we initially put in. And that should give you something like $616.35. All right, so that's it for today's lesson. What I'd like you guys to do is try all the odd problems, okay, on homework 10 here. Hey, remember, keep an eye out. Whenever you see the word compound is when you're going to use that compound interest problem. Otherwise, you're just going to use your normal exponential growth and decay, guys. Okay, so I hope you guys have a great day.